Hey there, everyone. Another lesson here from the finance section of this course. So we're looking at present value. And so present value is the money you have to invest now in the present, so that you end up with a certain amount of money later on. It's a pretty common question, right? How much do I have to put away so that I'll have money for later? We are going to look a little bit at the more realistic option of like putting away money each month or each week or whatever. This is just if you put a lump sum of money in, let it grow. Okay. So if you're planning on putting away money to meet your financial goals, so you have a certain amount of money later on, you're going to invest a certain amount of money now in the present, right? That's your present value. And yeah, it's going to grow to be a certain amount in the future. So this person, Raja, is planning a trip to Europe in 4 years, and they will need $3,500 at that time. So how much must the person invest today at 7% per year, compounded annually, to have the $3,500 4 years from now? So if we didn't have sort of the math skills to solve and work with the equation, I guess we could do it like trial and error almost, right? Just plug in a value, try a number, and see what you get, and keep modifying that. But of course, we can work algebraically with this nice equation, right? And so we can set, instead of putting the number in for P like we normally would, the red part there, instead we're going to put the 3,500 for this question in for A. And then the P would be left as a variable to solve for. So your interest rate and your numbers are going to go in like normal, right? So you're just going to use regular algebra solving processes, like this question here, where if you had that equation, you'd divide both sides by 3 and get that x equals 4, right? The number that matches the equation. So it should be pretty easy to do. So in this question, we had the $3,500 we wanted to end up with. The P, we're just going to leave it as a variable. The interest rate is going to go in, and so on, right? We had in the question compounding annually. So not really dividing the interest rate up at all, or you can think of it as dividing into one piece. And it's talking about 4 years, right? So that's why we have a 4. So there's everything in place. The P is just there so we can solve for it. I guess I should have had that stuff, but we talked about it. And so, I would just evaluate this as a number. So get this as a number, right? Add the 7% on and so on. So you get your 1.31 once you've done whatever, 1.07 to the power of 4. And then, of course, you just solve for P. So just like the example question I showed you where we divided by 3 on both sides. Just divide by 1.31. Gives you a present value of $2,670.13. So if that amount of money was invested at 7%, and 4 years later, you have $3,500. Okay, so it grew to meet the needs that you wanted to have, the value you wanted to have. All right, so here's another example. This person received $5,000 on her 21st birthday, and that amount of money was the result of an investment her parents made on the day she was born. Okay, so if the investment earned 10.25%, that's not very realistic, but compounded quarterly, then how much did her parents invest? Okay, so let's go through the bits and pieces here. So receive this amount here, so that's your A, and 21st birthday, right? So that is the end value, and we're talking about the interest rate. So I equals the 10.25%, but we are going to, because it's compounded quarterly, we are going to, let's color code this actually, compounded quarterly. So we're going to be dividing that thing by 4. Okay, and also up here reminds me that's to be multiplied by 4, right? So basically I've shown the given information up there by just circling, which is a nice efficient way to do it. So our equation gets the numbers plugged into it. So we're going to have our $5,000 that B. Young ended up with. Principal that was invested, we don't know what that is. We're going to figure it out. 1 plus that 10.25% divided by 4 for quarterly. Dividing that interest rate up into 4 little pieces, so we can apply it 4 times per year, right? So we have our 21 years times the 4. And that's how many compounding periods are in that. I should rewrite this actually up here. N equals 21, and then the times 4. Right, so what we have. And so you would evaluate that stuff. You'd get values here. So let's do that. You can do your 10.25. Divide that by 100, of course, to convert to a decimal, and then divide it by 4. So 1.02565. 1.02565. And that's going to be to the power of 4 times the 20 and be 80, so 84, right? So we are going to add 1 to that, put it to the power of 84. Gives me that number there, so 8.376. Basically, banks would keep at least the 7 decimal places, possibly more, but I've always been told they keep 7. This day and age, they probably keep more. Computers can keep a lot. And then we end up with thanks, no problem. I didn't put my recording in progress sign on the door. Normally there are interruptions, but just happened to be the day. All right, so here we go. We just divide both sides by 8.376 and so on, right? So that number's in there for me. I'm going to use the feature of the calculator where I can store that thing, and then I can do 5,000 divide by memory recall equals. Most calculators have that feature. 596.94 in the end. We just round the money value, so my 596.94. So that means that the parents only put away $596.94. It was probably like $600 or whatever, but we rounded to nice numbers, you know. But therefore, you know, that amount of money was invested, etc. Right? Some kind of a communication statement at the end. Pretty obviously, that's a huge interest rate, right? So I'm not going to expect that kind of return necessarily, but yeah, same numbers as before. I just double check and make sure I didn't make a mistake. But yeah, so that is just the idea of just solving for the money you put away now. That's your P. So instead of being given it and seeing what it grows to, instead you're given what it grows to and asked to solve for it. So lots of practice questions, some practice questions there for you to do and submit, and make sure to ask questions if you need help. All right, talk to you later.